So derivatives. So basically the definition is a slope of a point on a curve. So there's two ways to find the derivatives. One definition of derivative, there's the formula, and the second one is the other ways like power rule, quotient rule, and product rule, and other ones. I'll get into it. So the definition of derivative, basically I already showed you the formula, so I'm just gonna put x squared. So just plug everything into the formula like so. Distribute the x plus h squared correctly, because I know a lot of people make mistakes on that, and then add in like terms. It's crucial to show your work so you don't make any mistakes. You cancel out the x squares because they cancel out, and then you cancel out the h's, and you get 2x plus h, and x is 0, h is 0, so it's equal to 2x. So that's the derivative of x squared. So the power rule, basically it's x to the nth power, and then it's equal to n times x to the n minus 1. So for example, x squared again, because it's simple, 2 minus 1, 2 in the front, 2 to x to the 1, so it's 2x. So the product rule, so basically the derivative of the product rule is the first one times the second derivative plus the second one times the first derivative. So let's say x squared times x plus 1. So we have x squared times the derivative of x plus 1, which is 1, plus v, which is x plus 1 times the derivative of x squared, which is 2x. And then we can multiply and simple it out, we get our answer. So the quotient rule. So like Ms. Castro said, high D low times low D high, high D low minus low D high over low squared. So we have our function x squared over x plus 1 to keep things simple and similar. So we have v, which is x plus 1 times the derivative of u, which is 2x, minus u, which is x squared, times the derivative of x plus 1, which is 1, all over x plus 1 squared, because the bottom you have to square it. And that's basically the quotient rule. So the constant multiple rule is basically when you have a constant times a variable, it just means that it's constant times the derivative of the variable. That's how you find the derivative. So 2x, the derivative is basically just 2, because the derivative of x is 1. So chain rule is basically for composite functions. So you find the derivative of the outside function and leave the inside the same, plus the derivative of the inside function. And basically we have sine over here, so is sine of x squared, the derivative of sine is cosine x squared, plus 2x, which is 2x is from the inside of the function x squared, that's the derivative of that. And so basically we're going to talk about how we got cosine from sine. So how did we find the derivative of sine? So basically we start graphing out our graph. We plug in our points. This is not drawn to scale. And we first graph out the sine graph. This is to prove that the derivative is cosine. So the slope of each part is basically 0, as I'm outlining right here, because we remember the derivative is basically the slope of each section. So as you see over there, that's increasing by 1, so it's positive 1. There's decreasing by 1, so it's negative 1. And basically once we plot our point, we're able to draw a graph. from this graph, you see that it's actually cosine. It's important to make your graph neat or else you'll be a bit confused. So this happens to a lot of the other graphs. So if you were to check with the other graphs, it would work like this too. So just remember these functions because it's better than just doing the graph over and over again. So the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, the derivative of negative cosine is sine. The derivative of tan is secant squared, the derivative of cotangent is negative cosine squared, the derivative of secant is secant times tan, and the derivative of cosecant is negative cosecant times cotangent. So let's talk about more rules for derivatives. These are things that you should just remember so that it makes your life easier, but it's okay. You can always prove it. So e to the power of x, the derivative will always equal e to the power of x. Same if it would have a constant. The derivative of ln x is 1 over x. So substitution. The derivative, you use u to take out like the numbers so that you make your equation and function less complicated. So as we took out 2 of the x, you found the derivative of 2x, which is 2, and then you found the derivative of root u. Root u is basically u to the 1/2, and then you use the power rule, then you get 1 over 2 root u, and then you plug in 2x again, and you have the 2, the derivative, you cancel out, you get 1 over root 2x. So yeah, that's it for derivatives. This was a quick session that was under 7.5 minutes.